So that's all you have to do algebraically to understand any 2x2 matrix. Right? You have to just project it and the results up. Now, what's the remaining part? The remaining part is that we understand now any matrix algebraically, right? We can break it up into simple pieces, those 4 pieces. And what do we do now? Well, now the goal is to bring this understanding to physics, right? Are we gaining anything by this? Well, actually, at this point, we already did gain something. So what did we? So what we're gaining is that this space of all 2x2 matrices corresponds in some sense to all possible so-called linear flows, right? Those physics flows that can be determined by a 2x2 matrix, determined by a linear function, all right? And then, among all those linear flows, we just identified 4 types of the flows, all right? This type, that type, this type, and that type. And algebra suggests these are 4 very simple types. These are 4 independent types. And anything else can be expressed in terms of those 4. And how exactly? Well, very simple way. You can say that any linear flow determined by any matrix is equal to some number times the flow of the first type. What's the flow of the first type? Well, we know what it is. It's explosion, right? So that matrix 1, 2, 3, 4 can be thought of as explosion with the rate 5 halves. 5 halves is exactly how fast everything is moving away from origin under that flow. What else do we know at this point? Well, we know that that matrix, 0, minus 1, this matrix, right, corresponds in physics to circulation. And therefore, once I compute this projection, I will get that matrix 0, minus 1, 1, 0 multiplied by some number. Does that number make sense in physics? Well, it is angular speed. So what you will actually compute algebraically, that component, it is exactly the angular speed of circulation. And what we are saying now is that this linear flow contributes circulation with that speed. So we figured 2 things that we understand so far, and there are 2 sort of mysterious things that we have to play with and understand and bring to physics and tell everybody that basically any linear flow is a combination of a little bit of expansion and a little bit of circulation, a little bit of deformation, and that's it. Right? Aren't we advancing in physics, in understanding flows? And moreover, remember, any flow, any possible flow at any point can be thought of as a combination of those 3 things. Expansion, circulation, deformation. That's it. You just have to figure out exactly those numbers. Angular speed, rate of expansion, rate of deformation. That's it. So, please practice computing those, including the deformation, rates of deformation, and I will finish that on Thursday.